So, my name is Corbin Clark. Today I'll be walking you through how the male endocrine system guides development throughout the entire human lifespan, beginning in the prenatal stage and continuing all the way to late adulthood. Our learning objectives, we're going to talk about the major male hormones such as testosterone, dihydrotestosterone, GnRH, luteinizing hormone, and follicle stimulating hormone, and some others. I'll explain how their secretions change over time, how they influence body systems, and what happens when these hormones are disrupted. At the end, I'm going to discuss congenital adrenal hyperplasia, a condition that alters natural endocrine processes starting early in development. During prenatal development, the male endocrine system plays a crucial role in forming the reproductive organs. Around the 6 weeks of gestation, the presence of the Y chromosome activates, which causes the undifferentiated gonads to become testes. Once the testes form, they begin producing key hormones that drive male development. The first major hormone is testosterone, which guides the formation of the internal male reproductive structure, including the epididymis, vas deferens, and seminal vesicles. Some of this testosterone is converted into DHT or dihydrotestosterone, which is even more potent. DHT is responsible for forming the external male genitalia, such as the penis and scrotum, as well as the prostate gland. Although the fetus is producing testosterone and DHT, the brain's control hormones, LH and FHS, are not yet fully active. Instead, the developing testes respond mostly to signals from the placenta. Luteinizing hormone and follicle stimulating hormone will become important later in life, but during prenatal development, it is testosterone and DHT that shape the formation of the male reproductive system. During infancy, males experience a unique development stage called mini-puberty, which occurs roughly between 1 and 6 months after birth. During this time, the baby's endocrine system briefly becomes active in a way that resembles a small version of puberty. The hypothalamus begins releasing GnRH, which signals the pituitary gland to produce luteinizing hormone and follicle stimulating hormone. LH stimulates cells in the testes to produce testosterone, and infants can temporarily reach hormone levels similar to adolescent boys. FHS helps the testes grow in supporting the early development of sperm and producing structures. The surge in testosterone contributes to the growth of the penis and testes, strengthens the programming of the reproductive system, and supports aspects of early brain and nervous system development related to male physiology. After about 6 months, LH and FHS and testosterone drop to very low levels once again and remain quiet until puberty begins later in childhood. During early childhood, from about ages 3 to 5, the male reproductive hormones like testosterone, luteinizing hormone, and follicle stimulating hormone remain very low. Instead, physical development during this stage is driven mainly by growth hormone or GH, along with IGF-1 and thyroid hormones. Growth hormones play a major role in increasing skeletal mass, lengthening the long bones, and strengthening the developing muscles and joints. As growth hormone levels rise in pulses throughout early childhood, bones grow rapidly, and skeletons become sturdier and coordination improves. IGF produces in response to growth hormone helps build cartilage and bone tissue, supporting height and overall body growth. Although the testes are quite quiet during this time, the endocrine system is actively preparing the male body for the dramatic changes that will come later in puberty. During middle to late childhood, from the ages 6 to 12, the male reproductive system is still mostly inactive, but the endocrine system is quietly preparing the body for puberty. One of the most important events in this stage is something called adrenarche, which when the adrenal glands begin producing weak androgens. These hormones are not as strong as testosterone, but they start early changes like increasing body odor, slight hair development, and gradual shifts in mood and behavior. At the same time, the brain is slowly increasing the sensitivity of the hypothalamus and pituitary gland. Even though LH and FHS remain low, the cells that will eventually control puberty are maturing and getting ready for their major activation in adolescence. Growth hormone and thyroid hormones continue supporting height, muscle development, and energy levels. Overall, this stage is like warming up the engine. The body isn't in puberty yet, but the hormonal groundwork is being laid for the major testosterone surge that will reshape the male body during adolescence. Adolescence begins around ages 12 to 13. It is a period of the most dramatic hormonal change in male development. The hypothalamus starts releasing GnRH in regular pulses, which activates the pituitary gland. In response, the pituitary releases luteinizing hormone and follicle-stimulating hormone, the two hormones that jumpstart puberty. Luteinizing hormone stimulates the testes to produce large amounts of testosterone, and follicle-stimulating hormone works with testosterone to activate sperm production. As testosterone levels rapidly rise, the body undergoes major physical changes. The voice deepens as the larynx grows, muscle mass and strength increase, and the shoulders broaden. Body hair appears on the face, chest, underarms, and is driven by testosterone in its more potent form, DHT. Bones lengthen quickly, leading to growth spurts, and the reproductive organs reach full size and function. This surge in testosterone reshapes nearly every body system, marking the transition from childhood to full biological adult. During early adulthood, typically from the late teens through the early 20s, the male endocrine reaches full maturity. This stage represents the peak hormonal stability, especially when it comes to testosterone, which is at its height and most consistent levels during this time. The hypothalamus continues releasing GnRH, which keeps the pituitary producing steady amounts of luteinizing hormone and follicle stimulating hormone. LH maintains testosterone production, supporting muscle strength, heavy libido, and normal sperm development. FHS, working alongside testosterone, ensuring ongoing spermatogenesis and peak fertility. These hormones also support strong bones, increased red blood cell production, healthy energy levels, and overall metabolic function. During early adulthood, testosterone helps maintain emotional stability, cognitive performance, and physical performance. Although small hormonal fluctuations occur, this period is mostly hormonally balanced and represents the height of male reproductive and physical capability. During middle adulthood, typically from the 30s to the 60s, men experience gradual but meaningful hormonal changes. The most important shift is a slow decline in testosterone, which begins around age 30 at a rate of about 1% per year. The hypothalamus and pituitary continues releasing GnRH, LH, and follicle-stimulating hormone, but the testes respond less strongly than they did in early adulthood. As testosterone levels decrease, several body systems are affected. Men may notice reduced muscle mass, slower metabolism, and an increase in body fat, particularly around the abdomen. Bone density gradually declines and energy levels may lower. Changes in libido, mood, or motivation can also occur as hormones levels shift. Sperm production continues, but fertility may slowly decrease due to reduced sperm mobility and quality. These hormonals don't happen all at once, they progress slowly over decades, but together they mark the transition from peak reproductive function into the later stages of adulthood. In late adulthood, typically from age 61 and onward, the male endocrine system undergoes significant hormonal changes, especially involving testosterone. By this stage, testosterone levels are much lower than in younger years, and the testes respond less effectively to signals from luteinizing hormone and follicle-stimulating hormone, even though the pituitary continues to reproduce them. This means that both testosterone production and sperm formation slow down considerably. Low testosterone affects multiple body systems. Men may experience decreased muscle mass and strength, reduced bone density, and a higher risk of osteoporosis. Fat tends to redistribute around the abdomen and metabolism slows. Energy levels, libido, and mood may also decline as hormonal support weakens. Cognitive functions such as memory, focus can be affected due to reduced androgen activity in the brain. Although sperm production doesn't completely stop, fertility decreases and overall endocrine function becomes less efficient. These changes reflect the natural aging of the male reproductive and hormonal systems. For my condition spotlight, I have congenital adrenal hyperplasia or CAH. It is a genetic disorder that affects how the adrenal glands make hormones. It is present at birth and is caused by a mutation in the genes responsible for producing certain adrenal enzymes. Because this enzyme is missing or not working correctly, the adrenal gland cannot make enough cortisol and sometimes cannot make enough aldosterone as well. In response, the brain sends stronger signals through ACTH that overstimulate the glands. Instead of making cortisol, the glands shift in overproducing androgens, which are male type hormones such as testosterone. In males, this usually will cause very early signs of puberty, such as deep voice, rapid growth, and early pubic hair, and it also lead to larger than expected genitals at birth, early muscle development, and a shorter overall adult height, and then fertility issues well into adulthood. This concludes my presentation.